Hi everyone. In this video, I am starting with a very new topic which is transient analysis. Now, transient analysis means analysis of the circuits when they are in transition state. Transition state means from one state to another state. We can take the example that we have a circuit in which we have a switch. When switch is off, that is one steady state. When we turn on the switch, so there will be transition. The appliance which is connected through that switch that will get turned on, current will increase. So current will increase from 0 to the final value. That final value is again steady state. So the transition from one state to another state comes under the transient analysis. Now in case of transient analysis, we will be dealing it under DC circuits only. This one is for DC circuits, not for AC. Now, what we had seen till now in DC circuits, we had only resistances and sources. We don't have the inductor and capacitor. Why? Because inductor behaves as short circuit when we connect across the DC supply, and capacitor behaves as open circuit when connected across DC supply. So they were not there in the analysis. But when we do the transient analysis, inductor and capacitor, they plays their role. Now what is their role? We know that the inductor has property that it opposes the instantaneous change in current. So as I am saying that when we switch on any circuit, if the current is initially 0, till now the current is 0, here we are turning on the switch. Ideally current should increase to its steady state value, let's say I, at the same instant. But because of inductor, it can't rise instantaneously. Instead of that, it will increase slowly like this. So there is transition from one state to another state. Initial stage was when current was 0, final stage is when current is equal to I. During that, in between this time period, this much, where the current was changing from 0 to final value, we are moving from one state to another state. This is the transition period. This one is actually transition period or transient time. Transient analysis is also known as by other names, sometimes by time response, or it's also known as step response. So I have taken the example of inductor, that how inductor plays when we have DC circuit. Similarly, if we have a capacitor in the circuit, then capacitor has a property that it opposes the instantaneous change in voltage. When it opposes the instantaneous change in voltage, so it will not allow the voltage to change from 0 to some final value in the same instant. Again, there is some time required to change the voltage from its initial value to the final value, that is the new value. So how the inductor and capacitor affects that comes under the transient analysis. So in transient analysis, we can have the combination of resistance and inductor, and we can have the combination of resistance and capacitor. But before moving on to their combinations, we need to understand that how the inductor behaves. Now let's say we have an inductor which is supplying having value L. Current through this is 0. Now, when we change the switch, either it's turning on or turning off, this inductor has property that the current will not change. So when current will not change, it means same current will continue to flow. So the current through inductor is same at the instant of switching as what it was before switching. So in case of transients, we have three different instants. T equal to 0 is instant of switching. Instant of switching means when we turn on or turn off the switch. T equal to 0 minus is instant just before switching. T equal to 0 plus is instant just after switching. So we have three different instants. Now in case of inductor, the current through the inductor is same at the instant of switching as what it was before switching, and even after switching it will remain same. So if the current through the inductor is initially 0, it will remain 0 after the switching as well. It will take some time to reach to its final value. Instantaneously it can't change from one value to another one. So at t equal to 0, we can say the inductor behaves as open circuit, and under steady state, inductor behaves as short circuit. Inductor behaves as short circuit, and then we find out the current. Steady state means time is equal to infinity, and then we find out the value of I infinity. Now that depends upon the circuit, whether there is any source, how many resistances are there. Accordingly we will have the value of I infinity that we can calculate depending upon the circuit. Now in case of this inductor can be connected in series with a resistor. I'm not going in the derivation part, that you can check from any of the book. The current through inductor, if we are having R and L connected in series, and here we have a source, and this is a switch which can be turned on and turned off. Then current through this inductor ILT is actually written as I infinity plus I0 minus I infinity into e raised to the minus t by tau, where tau is the time constant of RL circuit given as L by R equivalent. R equivalent is equivalent resistance seen from inductor terminals. Like in this case, if we have only one resistance, then it will be L by R. If we have multiple resistances, then we need to calculate that what is the equivalent resistance seen from the inductor terminals. So with this expression, we can calculate the value of IL. So when we have this expression, we need to calculate that what is the final value of current through the inductor, what is the initial value of the current through the inductor, and we need to calculate the time constants. So in solving the transient problems, we have to follow three steps. We have to do the calculations before switching, then after switching, and then we need to calculate the time constant. So this is a formula which we will be using in RL series circuits. Similarly, we can have RC series circuit. Now for understanding RC series circuit, we need to understand that how the capacitor behaves. If we have a capacitor and we switch on the DC supply across the capacitor. Now this capacitor has property that it opposes the instantaneous change in voltage. When it opposes the instantaneous change in voltage, it means the voltage across the capacitor at the instant of switching is same as voltage across the capacitor before switching, that is 0 minus, and even just after switching it will remain same. So Vc0 minus is same as Vc0 as well as Vc0 plus. And under steady state, capacitor behaves as open circuit, and we can calculate the voltage across the open circuit. Steady state again means t equal to infinity. So if we have RC series circuit, again not going in the mathematical derivation part for RC series circuit, I am just writing the expression for calculating the voltage across the capacitor as a function of time. Vct can be calculated as Vc infinity plus Vc0 minus Vc infinity into e raised to power minus t by tau, where tau is C into R equivalent, time constant of RC series circuit. So again in this case, we need to find out final value of voltage across the capacitor, Vc infinity, that is Vc infinity we can find out after switching. Vc0, voltage across the capacitor. Since the voltage across the capacitor at the instant of switching is same as what it was before switching, so we need to do the calculations for before switching circuit, and then we need to calculate tau. Now we need to note down that in both the cases, whether it's RL circuit or RC circuit, tau is calculated from the conditions which are there after switching. So we need to calculate R equivalent from after switching conditions, and then we can have the value of time constant. Now in both the cases, whether it's RL circuit or RC circuit, there are three major steps. We need to do the calculations before switching, then after switching, and part third step is we have to calculate the time constant. Now in before switching, in case of RL circuit we need to calculate I0, in case of RC circuit we need to calculate V0. After switching we will calculate I infinity in case of RL circuit, in case of RC circuit we will calculate V infinity. And here we will calculate tau, which is equal to L by R equivalent. In case of RC, it's R equivalent into C. One thing more, now if we want to find out that what is the current through the capacitor in terms of time, then we can use the expression of Vc, since the current through capacitor can be calculated as C dVc by dt. If the question is in case of RC circuit, we have to obtain the expression for current through the capacitor, then firstly we need to find out the value of voltage across the capacitor, and then we can use it in this equation to obtain the current through the capacitor. Similarly, in case of RL circuit, we first obtain the current through the inductor, and if it is asked that we have to find out the voltage across this inductor, let's say VLT, then this VLT can be calculated by using L di by dt. So this is how we do the calculations. In next video, I will solve the problems for transient analysis for RL series circuit followed by RC series circuit. Thank you for watching this video.